reaction path fouling. That means air flue gas path is very clear. Something, if it is not obstructing something, flue gas velocity will get reduced. Minimum popcorn ash. I will discuss more about this popcorn ash. Okay. Then environmentally driven factors for optimum combustion. Satisfactory low LOI, loss of ignition, that means unburned carbon in the fly ash. ESP performance satisfactory. Acceptable levels of NOx, acceptable level of CO, and acceptable level of sulfur also, sulfur dioxide. And particulate matter, SPM, what we call. These are environmental parameters. So boiler functioning combustion optimization has efficiency, effectiveness, as well as environmental regulatory matters also controlling. It has all the impact on that. So let us now see what are the factors which will affect the optimization of combustion. There are 13 prerequisites for optimum combustion in a tangential fired boilers. I request participants to interact with me in this because these are the things which are O&M. O&M people has to bother more about it. Prerequisites, I mean, your combustion has to be proper, has two aspects I discussed. One is the fuel input. You have to give proper coal. Even if you give proper coal, if the equipments in which you are using this coal, right from feeder, pulverizer, coal pipes, boiler condition, if they are not properly tuned, if they are not properly tested, then combustion problem will be there. Okay. If they are okay and if input is not okay, then also combustion problem will be there. So I am taking first those 13 prerequisites for optimum combustion for tangential fire boiler, and 50% of them are pulverizer related, mill related, pulverizer related. Let us discuss one by one of them. First, furnace exit must be oxidizing, preferably no less than 3% oxygen. That means actually, if you are measuring the oxygen at economizer outlet, and if this oxygen indicates 2.5 to 3%, 2.5 to 3% of oxygen, or as per your design value.
Sir, eco outlet or APH outlet?
Eco outlet. Eco outlet, you will be APH inlet, you will be measuring. Okay. Because APH outlet, when you measure oxygen, what happens? Even eco outlet also problem. First, let me explain you why it is not APH outlet. APH outlet, when you measure, if there is a seal leakage, air preheater में जो seal leakage अगर रहेगा, okay, that seal leakage will air leakage through the seals when it is there. If any air leakage is there, that also gets added to the oxygen and gives a wrong indication. So the best is to, there are traditional. What happens is first is to measure at air preheater outlet. Then came to air preheater inlet. Now air preheater performance also we require to monitor, and air preheater performance is you measure oxygen at air preheater inlet, air preheater outlet, see whether is this there as per design, means some amount of leakage is already allowed in the air preheater. If more leakage is there, then this oxygen will increase. Then this will indicate air preheater performance also. But it is not a combustion performance. So air preheater inlet when you measure, then it gives a clear picture of that. Economizer outlet, air preheater inlet, because by that time actually combustion is complete. In fact, combustion is complete earlier itself. But even measuring economizer outlet, air preheater inlet, oxygen, and deciding about the tuning of the combustion also is wrong. I am discussing about that issue, why it is wrong. This is a major problem in O&M area. What happens is earlier we were not having CO measurement concept. Even CO2 measurement concept also was not there, maybe around 10 years back. If you see 10 to 12 years back in Indian power boilers. We used to measure only O2 and then say measure O2 at economizer outlet, air preheater inlet, and it should be 2.5 to 3% in flue gas. Okay, fine. If it is less, you increase the FD fan loading. Pump in more air because it is giving an indication is air is less. On the other side, if air is more, 4.5% air is there, or oxygen is more, you reduce the FD fan loading. Go on reducing FD fan loading, this also gets reduced. Oxygen outlet also gets reduced. But one tricky issue is there here, which is called ingrace, furnace ingrace. If we do not do the proper overhauling, if we do not do the furnace tightness test properly, there is a air ingress because furnace is operating under vacuum. It is sucking the air from all loose points, not properly welded points, because we do not do the furnace tightness test of the overhaul properly. I don't say that they don't do it. It is done. But if it is done in a hydro test manner, that is, if you stop the fan, pressurize the furnace and see the real leakages from the duct, from the rooftop, furnace rooftop. If you see and attend to it vigorously and make furnace tight, it is supposed to be tight. It is not supposed to suck any oxygen from outside. So what happens is, after the combustion zone, you have an air ingress from the rooftop, and that air is entering in the flue gas and giving you an indication saying that this is the combustion air. It is not taking part in the combustion. Actually, combustion air is less. Combustion air is less, but your air is more in the economizer outlet. So, if you measure CO along with O2, if O2 is 2.5 and if CO is 13, if CO is around, I have seen 1000 ppm, 1200 ppm, that means incomplete combustion. O2 is fine, but why incomplete combustion? That means this O2 what is showing 2.5 to 3% or even 4%, this O2 is wrong. If complete combustion is there, CO will be 150 to 200 ppm. It will not be more than 200 ppm if combustion is complete. So if you measure CO along with oxygen at combustion zone, at economizer outlet, air filter inlet, and if CO is 200 to 200, 150 to 200 ppm and O2 is 2.5 to 3, you can be rest assured it is okay. But many times we have seen, if we measure CO, it will indicate an incomplete combustion, but oxygen indicates a complete combustion, which cannot happen. And that is possible only when there is a furnace ingrace from various locations. Yeah.
Sir, how to measure CO?
CO, lot of equipments are available, CO measurement. CO measurement, extra CO analyzer is there, the optical type of CO analyzers are there, extractive type of CO analyzers are there. Nowadays, combustion analyzer is coming. It will take a sample of the flue gas, extractive type of sample of the flue gas, and it will give you CO2, it will give CO, it will give O2, it will give even sulfur dioxide and nitric oxide also. And portable also is available. If you don't want to go in online, you can have a portable one. Means once in 3 days, once in 2 days, you can go suck the air, suck the flue gas sample and do the measurement. Now, in order to come out of this problem of ingrace, actually what is supposed to be measured, oxygen, where is the ideal location to measure the oxygen? You want to know that this oxygen is after the combustion, immediately after the combustion. So, if the burner zone is over, immediately after the combustion, before it enters the superheater zone, if you measure, the problem of measurement there is at the high temperature. Earlier, we were not having the oxygen probes which can withstand 900 degrees, 800 degrees. There, the temperature is around 900, 800 degrees. It cannot. But now, zirconium oxide probes have come in the market around 10 years back. So, people shifted to the oxygen measurement from the low zone to the combustion zone, immediately after the combustion zone. Dramatic results were achieved. There, oxygen is showing 1.2 to 1.3. And oxygen at the economizer outlet air filter inlet showing 4.5. That means air ingress only. And operation people thinking that if the air is 4.5 or 4, air, when they reduce the FD fan loading, still combustion zone will have a less air and slagging will take place. And all the clinker formation, because the effect of under oxidation is the clinker formation. clinker formation, incomplete combustion, and boiler slagging will take place. Very difficult to handle in such things. So the best measurement is to do the oxygen measurement and CO measurement at the immediately after the combustion zone. High temperature probes are available nowadays, which can withstand that. Extractive is available, online is available, portable is available. Whichever you want, you can have it. But correlating this measurement at the combustion zone is very important. It gives you a combustion knowledge also. At the same time, it will tell you the ingress, your furnace conditions also it will tell you. And definitely when this oxygen is 1.2 to 2 and when you pump in more air, your economizer outlet air also will be more, oxygen will be more. It may go up to 4.5 to 5. I have seen in some cases it goes up to 5, 5.5, but slagging is reduced. Clinkering is reduced. That is clear indication that the problem was there. So we have to be very careful about the measurements. You are able to see the slide?
Yes, sir.
Yeah, some change was there. Somebody switched this slide. Okay, that is about the oxygen measurement. Any discussion, any doubt, any clarifications you need on oxygen measurement? If anybody is interested furthermore, at the end of the discussion, I will show you some suppliers catalog also, where you can get. Amtech is one of the catalog. Rosemount is one, where you can get such kind of measurements. Okay. Next is
Sir,
Yeah.
hello.
yeah, please.
Sir, the value. If suppose we are not having the online analyzer at the APH inlet, do we have any indication through the chimney outlet CO value? If it is coming more, or what is the range it should be?
If you go away from the combustion zone, more problem will take place. That is not the real indication of the combustion, because you are adding more and more elements. ESP is there. If there is any secondary combustion taking place in ESP, it will have a misnomer in that. So I don't advise look at the chimney for combustion process. Look at the chimney for emission purpose, for pollution control measurement purpose, not for doing the combustion purpose. Do not look at the chimney for combustion purpose, because gone are those old days where okay यार वो black smoke दिख रहा है तो combustion is not proper, थोड़ा adjust करो. Because that is very rough adjustments. Now we have gone with very good instruments are available, very efficient instruments are available. So looking at chimney and doing the combustion analysis is a very primitive concept. Very primitive concept.
Okay, sir.
Okay. Next is that next prerequisite for one.
Sir, I want to add something.
Yeah, please.
At the light up condition, maybe CO fluctuates, and looking at CO, we fluctuate AF. But when the furnace is stabilized,
Yeah.
when we achieve full load, hardly CO fluctuates. What we have seen, we daily take 2 to 3 readings in a shift. What we see, CO never fluctuates.
Yeah, exactly. If combustion is proper, CO will not fluctuate. If combustion is proper, CO will not fluctuate. But CO alone is not the indication of proper combustion. I will come to that. Because CO will tell you that heat generation is efficient. Now, unburnt carbon temperature increase is heat utilization. If the heat utilization, just seeing the CO, I cannot say that boiler is okay. I can say combustion is okay. That means efficient generation is okay. But if the generated heat is not utilized properly, then also problems will be there. Those problems will come to in the discussion. We'll see that. Because looking at boiler as a whole, for example, if there is an unburnt carbon, high unburnt carbon in the bottom ash, it can be due to poor combustion, or combustion is okay, it can be due to the poor absorption of the heat. because heat is not being absorbed, so combustion chamber is not having proper this thing, high temperature is coming, combustion is not taking place properly, and because of that the unburned carbon is coming in the bottom ash. So we need to look at it as an integrated way. Efficient generation of heat as well as efficient utilization of heat, both have to be seen in integrated way. Okay, many times CO if it is not fluctuating, it is very good, but added to that some more parameters also you have to look at it. I will come to those parameters. What are those parameters? Okay, next is fuel lines balanced to each burner by clean air test plus or minus 2%. Whenever you are feeding a fuel, if the fuel is being fed to the furnace by 4 corners, all the 4 corners have to be balanced for air as well as coal, and you have to do this what is known as clean air test. When the mill is out, you do the clean air test, and the difference between the velocities should not be more than plus or minus 2%. It should be within plus or minus 2%. If it is not within plus or minus 2%, it indicates an unbalanced flow of air. Whenever unbalanced flow of air takes place through the pipelines, your tangential fired boilers may, what is known as fireball concept, will not take place, because more air will be there in one burner, less air will be there in other burners. Whenever more air is there in one burner, that fuel will go tangentially further. The water valve tubes near to that particular burner will be underheated. Water valve tubes away from that will be overheated. You have uneven heating of water valve tubes. And because of that, even sometimes your drum level also will be varying, fluctuating, one side low, one side high. People might have experienced this. Some mill combination, you change it, your drum level will get balanced. So the screen changing, why it is taking place? Somebody is changing the screen. Please do not change the screen. I request all participants not change the screen. Okay, you are able to see the screen slideshow?
Yes, sir.
Yeah. So what happens is that
Yes, sir.
in case if there is no balanced fuel lines, uneven flow through this particular will create a disturbance in the fireball, and any disturbance in the fireball, uneven heating will be there. This is another problem of heat utilization, which will impact the combustion also. Then next, fuel lines balanced by dirty air test using a dirty air velocity probe. Dirty air means it is the air mixed with coal particles, that is pulverized fuel. When mill is running, you will be doing this test. All 4 pipes, you will be doing this dirty air velocity test. Coal plus air, both. That will be plus or minus 5%. Fuel lines balanced in fuel flow, plus or minus 10% or better, that is only coal, right? So fuel lines fineness shall be 75% or more particles passing through 200 mesh. Fineness is having a lot of impact on the combustion. So fineness should be as per the design. Primary airflow shall be accurately measured and controlled to plus or minus 3%. This is one of the prerequisites. If the primary air is more, secondary air is less, there is a ratio, air to fuel ratio is there. If primary airflow is more, what happens? What is the impact of primary airflow more? If the airflow is more, primary is doing 2 jobs. One is that preheating of the coal, because it is a heated air, and as well as it is acting as a transport mechanism to carry the coal from the mill pulverizer to the furnace. If airflow is more, transit time of the coal in the combustion zone will be less, because it is propelling air with a high velocity. If we increase primary airflow, what happens is that coal particles will be carried away fast, and it will not have that resident time of 1 to 2 seconds. When primary flow is less, particle will when the flow velocity is less, particles will go to the unburned carbon. It will reflect as an unburned carbon because it is not having sufficient capacity or flow to take it to the burner and combustion zone. So this has to be, flow measurement has to be very good and control also has to be very good. Overfire shall be accurately measured and controlled plus or minus 3% accuracy. Primary air or fuel ratio shall be accurately controlled. Fuel line minimum velocity should be 3300 fpm. Mechanical tolerances of burners in the overhauling, burner tilt and damper shall be plus or minus 2 degrees. Secondary air distribution, SADC what we call, to the burner should be plus or minus within 5% to 10%. Fuel feed to the pulverizer should be smooth during load changes and measured and controlled as accurately as possible. Load cell equipped with geometric feeder is preferable. Fuel feed quality and size should be consistent. Consistent rock hole sizing of the feed to the pulverizer is a good start. That means these prerequisites is taking care of inputs as well as equipment conditions. For anything, process has to be all right. Your equipment also has to be tuned in a fashion. It gives a maximum good result as well as inputs have to be proper. If inputs are not proper, also problem will be there. If the equipment also is not in good condition, then problem will be there. So for doing optimization of combustion, a prerequisite is that your clean air test, dirty air test, airflow velocity test, then tuning of primary airflow, and then calibration of gravimetric feeders for taking care of the weight of the coal. All these things are to be tuned and made it ready. 50% of these problems are related to the pulverizers. So impact of that, how it is seen during the O&M phase, that we will see one by one. Same thing, we have put it in a pictorial fashion. Why these 13 prerequisites we have discussed in detail is, there is a saying, combustion is nothing but inject the fuel, inject the air and operate your burners so that combustion takes place. Once your fuel is injected, once your air is injected, you do not have any control over it. That means if the fuel lines are unbalanced, there will be unbalanced flow of air. If primary air accuracy measurement is not there, if gravimetric feeder coal flow measurement is not proper, once you enter the fuel and air, you do not have any control for the combustion. All controls what is to be done before entering into the furnace, it is to be done. After this, what you have? You have definitely control over effective utilization of the heat through soot blowing, through maintaining cleanliness. After effects you can come to know. But the tuning of the boiler, when we say optimum combustion has to take place and boiler tuning has to be done, means you have to bother for these 13 prerequisites. So if any of you are O&M, please look at all these dirty air test when it is done last for the mills. Clean air test when it is done. What are the results of clean air test? What are the results of dirty air test? What are the gravimetric feeder calibration? How it is done? What is the accuracy in this? And input side, coal which is being fed. What is the as fired calorific value of the coal? Don't take it calorific value of the coal supplied, because by the time it comes to your feeder, it might have lost some kilocalories. So if you think that you have put a coal of 3,700 kilocalories supplied by the coal mines, at the measurement load point you have measured 3,700. But if it has already lost some 300-400 kilocalories during the transport through the heat of evaporation, storage, for anything, if it has lost, then you will be a misnomer. You are feeding as fired coal characteristic you have to see. So feeder ka sample leke you can measure the calorific value of that. Then only you are maintaining the prerequisites for optimum combustion. Okay. Now, over. You have injected the fuel, you have injected the air. Now, as an operator, आपका हाथ में क्या है? What is there in your hand to know that your combustion is optimum or not? What are the symptoms which will tell you that boiler is not performing okay, either because of combustion or because of boiler condition, which are integrated together? The first and foremost, if you see temperatures, I'll start with high gas temperature. Either combustion is not proper or utilization of heat which is coming out of combustion, if it is not proper, you will get it into flue gas temperature at furnace exit greater than 1177 furnace exit. Here, furnace exit. Okay. This is called stratified flue gas temperature. If flue gas temperature stratified means a furnace, large furnace, especially 500 megawatt and above, even 200 megawatt also furnace is big. If you do measurement with one particular probe and say this is the temperature, it is wrong. You should have a network of flue gas temperature measurement, because there is something called stratification which takes place in the flue gas. Stratification means in the center the temperature will be different, in the sides temperature will be different. So because flue gas has major velocity at the center and less velocity at the sides because of the frictional forces, so the temperature profile will be different. You need to have temperature profile of the furnace right from burner up to the air preheater. You should have a temperature profile, how the temperatures are dropping. If we have that profile, you can come to know where the deposition has taken place. Probably हो सकता है कि temperature is already here. This temperature in the flue gas, it has to give rise to superheater reheater tubes, but it is not. It is not. So because of that, the temperature may be high. So here deposition may be taking place, or tube may be having some problem. Flow may not be inside some material got stuck up. Steam flow is not proper. Because of that, heat exchange is not proper. So any one indication is resulting into high gas temperature. So if your flue gas exit temperature, single most indication that your boiler is not okay. So you need to measure not only at one point, you need to measure at economizer outlet, okay, at air preheater outlet, then you get a temperature profile. In fact, nowadays, acoustic measurement of temperature of flue gas is available, like acoustic steam leak detection system. There is an acoustic steam temperature measurement of furnace by putting 24 to 30 probes. They give you a spatial temperature measurement. Combustion zone में कितना है temperature, सुपरहीटर जोन में कितना है, सेकंड पास में कितना है, इकोनोमाइजर इनलेट में कितना है, इकोनोमाइजर आउटलेट में कितना है. Like I will show you one time. Like they will show you temperature profile of the across furnace. Entire furnace का temperature profile क्या है? वो छोड़ के हम लोग प्रोसेस P&ID में जो लिखा है only 2 or 3 लोकेशन में टेम्परेचर मेजर करेंगे, it will not be giving proper indication to us. So this is the first one, high flue gas temperature. Next is your steam and reheater and superheater steam temperature and attemperation. If the attemperation and steam temperature right and left, balance if it is not there, if high or low temperature, metal temperatures inside, okay. So this and attemperation, this also gives you an indication that something is not correct in the boiler. It's having a impact on combustion. Occasionally, you will have problem in the boiler drum level. This, I think, if any operation people have experienced it, please share with me. We have experienced it very thoroughly. What happens is, in case of fireball is not proper, uneven heating takes place. Natural circulation or even forced circulation boilers, the drum level maintaining will have impact on the water wall tubes, riser tubes, especially riser tubes, inside where water and steam mixture is there. If uneven temperature is there in the furnace, your drum level will be uneven. One side more, one side less. People were thinking, how it can happen? It is impossible because it is geometrically balanced. So water cannot stay like this in the slant. It indicates an uneven temperature profile of your heating zone. Okay, there is another one. Now fouling and slagging. Yeah, please. Any question?
If there is drum, suppose we have 2-3 units, and in 1 or 2 units we are having frequent drum level changes during last drop soot blowing.
Yeah.
Then will it indicate about our combustion process? Is there a
100%,
problem?
100%. Your soot blowing is not effective at all. Either you are doing under soot blowing or you are doing over soot blowing.
So how to optimize that? We have to do it.
Do we have soot blowing temperature measurement? Anything is there? Do we have any additional temperature measurements for soot blower optimization?
If we are having the drain temperatures of the soot.
No. Drain temperature में actually देखिए boiler में soot blowing effectiveness will be seen. Only the whole thrust of soot blowing, they say that you have to do soot blowing to remove the soot. So for that you should know where the soot is there. If we do not know where the soot is there, and the conventional way of doing soot blowing is shift में this particular one to this wall blowers you operate, next shift this wall blower to this wall blower you operate, and we are seeing soot blower effectiveness in terms of input. That means soot blower temperature, it is okay or not. Wet steam I am not sending it. I am sending the dry and saturated steam of proper temperature without any water content. Fine. Input is fine. But where it is going and removing the soot, there actually soot should be there.